I am Prabhavati K, Assistant Professor and Research Scholar, belong to Department of ECE, BGS Institute of Technology, Adi Chinchanagiri University, Karnataka, India. Before commencing my presentation, I would like to thank International Research Awards on Computer Vision and also Science Father for giving me this wonderful opportunity. My research topic is design and development of efficient encryption techniques for the security of medical images in the cloud storage. As we all know that due to the advancement in technology, multimedia data such as image, voice and video has to be protected against security threats during transmission. Multimedia data requires either full encryption or selective encryption depending upon the application requirements. For some of the applications like military and law enforcement applications, they require full encryption because the whole image will contain the secured information. But there are some applications that demands security on a lower level. In such applications, selective encryption techniques are preferred. One such application is medical image security. Medical image encryption is an important technique to achieve security for medical images. For medical images, small amount of information encryption is enough to secure the data. Therefore, full encryption is not required. And also, existing full image encryption algorithms may be more complex and it also takes more processing time. And also, it is not suitable for some real-time applications. In selective image encryption, only selected portion of the image, that is region of interest, is encrypted, which leads to low computation cost and time, which is an important asset in wireless and portable multimedia systems. And also, competitive growth in efficient and reliable cloud storage and cloud computing services have resulted in low-cost storage of medical images with an additional benefit of outsourced cloud computing and authorized sharing. But due to sensitive and personal information carried by medical images, the privacy and security of medical images are important in the cloud environment, which is controlled by the external entity. Therefore, it is very important to secure medical images from the unauthorized access. A proper privacy and security system should be adopted or implemented from the source of the medical images while achieving the security and also availing the services of the cloud. So this is about the history, why we need to secure the medical images. There was a biggest incident in medical history so far, which is happened in US. Medical records were stolen that belonged to 4.5 million American patients of 2,206 hospitals across 29 states during April and June 2014, which was stealing medical records is not a North American problem. It happens everywhere in the world. For example, in 2012, hackers encrypted the entire database of an Australian medical center. So, uh, this says why we have to secure medical images. This is the general model for image encryption and decryption process. So here we'll consider the input medical image which is given to the encryption algorithm. So that encryption technique mainly works and controlled by encryption key. So that encrypted image will be called as a cipher image. This cipher image will be transmitted through the public channel. Then by applying decryption process, the intended receiver will receive the original medical image by using the decryption key. So here the encryption key and the decryption key both are same, and this is called private encryption technique, that is symmetric based encryption technique. The proposed forecast three efficient encryption schemes for medical image encryption, such as multiple chaotic systems, full and selective encryption. Then third one is homomorphic encryption. More than one chaotic streams are used to encrypt the image to provide a higher degree of security compared to a single chaotic stream encryption. The meaning of chaos is it's a special sequence used for both encryption and decryption process. The main important thing in chaos we have to observe is it's very sensitive to the initial condition, periodicity, and also randomness. It will be greatly used in the encryption technique of medical images. And also it is of higher speed with low cost. Therefore, it is the best candidate than the conventional methods for multimedia data encryption. Full and selective encryption. Complete image will be encrypted for privacy. In selective encryption, only region of interest have to be encrypted for privacy. Homomorphic encryption. Medical image owner homomorphically encrypt the plain medical images and transmits them to the cloud server for storage, processing, and further activities. The cloud server in turn provides storage, higher computational capacity, and authorized distribution of stored data for multiple end users. These are the objectives of my research work. So, our objective is to develop efficient full image encryption based on blockwise approach and chaotic maps. Then, to develop selective image encryption using zigzag transform and logistic sign map. The third objective is to develop reversible de-identification of specific regions by randomized joint encryption. Evaluate the proposed techniques with reference to the existing scheme and security analysis against various attacks. So this is the proposed block diagram of objective 1. So here the input image is taken, and using the input image itself, we generate secret key. That is why it is called self-adaptive. So secret key, using input image, here we are going to generate 4 keys, key 1, key 2, key 3 and key 4 using Hilbert transform. So input image is divided into blocks of 8 cross 8 subblocks represented as B1, B2, B3, etc. Bn. According to Hilbert scan pattern, shuffle the pixels in every 8 cross 8 subblocks. Determine P and Q values from key 2 and key 4. Shuffle the interblocks of the permuted image using Arnold cat map. Update ACM by taking previous cat matrix as input for current permutation. We generate key image using LSIC with the help of key 3. Finally, diffusion is carried out by bitwise XOR operation between the key image and the permuted image to get the encrypted image. So here, this is the procedure for secret key generation. So each block, an input image will be divided into 4 equal blocks. Key 1, key 2, key 3, key 4 will be generated corresponding to B1, B2, B3, B4. Key 1 is used for selecting whether Hilbert transform has to be scanned from the left or right. If the key 1 answer is 1, then scan starts from left. If the key 1 answer is 0, then the scan starts from right side. Key 2 and key 4 are the values of P and Q for Arnold cat map, which is used for interblock permutation. Then using key 3, diffusion operation will be done with the help of cipher image called LSIC. Finally, the encrypted image will get. In encryption process, there are 2 operations. The confusion is carried out by blockwise permutation, intra-block using Hilbert transform, interblock using Arnold cat map. Diffusion is implemented using Latin square, 'square' 'image' cipher. 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 'Square' 'image' c These are the parameters we are going to evaluate for the measurement of security. That is whether our proposed scheme is better compared to the existing one. Histogram analysis entropy, mean square error, peak signal to noise ratio, number of pixels change rate, and unified average changing intensity, SSI, IM, structural similarity index measure. So these are the results of our encryption technique. Here I have taken the data set of 6 different images, ultrasound image, MRI, and X-ray images, which are taken from mm, National Library of Medicine's open access biomedical images search engine. So these are the results. And this our proposed technique is compared with the existing one, which says our proposed system is giving better security compared to the existing in terms of NPCR, UACI, peak signal to noise ratio, structural similarity index measure, and also in terms of encryption time. Conclusion. While storing and transmitting any medical information, confidentiality is one of the most important necessity which is to be addressed by encryption. This means the information should be protected not only during transforming from a medical center to another one, but also during storage of the information in the database of the medical center. The main objective of this research is to secure the medical images efficiently using different techniques. Once again, I would like to thank International Research Awards on Computer Vision and Science Father for giving me this wonderful opportunity to present. I feel honored to be the recipient of such a prestigious award. Thank you.